Hello and welcome to this video where we'll be comparing Rust and C++, two of the most popular systems programming languages used today. While both languages share similarities, they also have distinct differences that make each language suitable for different use cases. In this video, I'll be comparing Rust and C++ in terms of performance, language features, use cases, adoption, and more, to help you decide which language is best for your project. When it comes to performance, both Rust and C++ are known for their speed and efficiency. However, there are some differences in performance between the two languages. Rust's focus on memory safety and strict compiler checks can lead to slightly slower performance compared to C++. This is because Rust's ownership model requires additional memory allocation and deallocation checks, which can slow down code execution. On the other hand, C++ is known for its raw performance and ability to optimize code to run at maximum speed. However, this comes at the cost of more complex syntax and an increased likelihood of memory errors. In benchmarks such as the computer language benchmarks game, C++ typically outperforms Rust in raw speed. However, Rust's performance is often on par with C++ and can even surpass it in certain scenarios. Rust and C++ have different approaches to language design, which can affect how they are used in practice. Rust is a modern language with a focus on memory safety and concurrency. It has a unique ownership model that prevents common memory errors such as null pointer dereferences and use-after-free bugs. Rust also has a strong type system with support for generics and traits. C++, on the other hand, is a mature language that has been around since the 1980s. It has a complex syntax that can be difficult to learn but also allows for fine-grained control over memory and low-level operations. C++ also has support for object-oriented programming, templates, and operator overloading. Rust and C++ are both systems programming languages that are used for low-level tasks such as operating systems, embedded systems, game engines, and network programming. However, each language has its strengths and weaknesses in different use cases. Rust is particularly well suited for concurrency and parallelism, thanks to its ownership model and lightweight threads. It is also a popular choice for network programming and web development, thanks to its modern syntax and libraries such as Rocket and Actix. C++, on the other hand, is often used for high-performance tasks such as game engines and scientific computing. It also has a large ecosystem of libraries and frameworks for a wide range of tasks, including Boost for general-purpose programming and Qt for GUI development. Both Rust and C++ have a strong following and are used in many high-profile projects. Rust has been gaining popularity in recent years thanks to its focus on memory safety and modern syntax. It is used by companies such as Mozilla, Microsoft, and Dropbox, as well as in open-source projects such as the Servo web browser engine and the Redux operating system. C++ has been a mainstay of systems programming for decades and is used in many mission-critical projects such as operating systems, game engines, and financial trading systems. It is also widely used in scientific computing and artificial intelligence. C++ is supported by a large ecosystem of libraries and frameworks and is often the language of choice for performance-critical tasks. So, that brings us to the end of this video. We have explored the similarities and differences between Rust and C++ in terms of performance, language features, use cases, adoption, and more. Remember, the best language for your project will depend on various factors, including your experience, project requirements, and available tools and libraries. If you found this video helpful, please give it a thumbs up and consider subscribing to our channel for more informative content on programming and technology. Feel free to leave any questions or suggestions in the comments section below. Thank you for watching, and until next time, happy coding!